Hello, welcome to another sharing session where we cover arc length and area of sector today. So I feel again we selectively pick up a few topics to work on because we feel that they are pretty commonly tested, and also at the same time this is what a lot of students tend to struggle with. All right, so here for question one, we have a diagram, two circles overlapping each other, right? And there is a common chord here in the middle. And they give us some numbers, however, the question didn't actually label them in the picture, right? So let's do that for them. We will label the 14 cm here, the 8 cm on the right side, and also the angle XPY equals to 0.8 radians. All right, so all this labeling, when it's done, then we begin with the question. So take note that in radians, these are the formula that should be given in your formula list in your school, right? If it's in radian mode, that means if your angle is not in degree, if it's in radian, then to find the circumference of the circle, it will just be r meter, right? If it's finding area of the sector or area of the circle, it will just be half r squared theta. Okay, this is for area in if you have the angle in radians, and this is for the arc length or the circumference if you have the angle in radians. But of course, if you talk about in degree mode, this is the ones that have been linked so far from primary 5 or primary 6 onwards, right? In degree mode, is basically 2 pi r times a fraction. That means if let's say it's 1/3 of the circle, then you times 1/3. You get it? Okay, then for the this is for the arc length, right? And for the area for circle or partial, sector, which is a partial circle. Remember, sector just means it's a small part of the circle, and arc is just basically the circumference of a small part of the circle. Okay, so right now we're all talking about a fraction of a complete circle. So same thing, a fraction times a formula for area of circle, which is pi r squared. Okay. So again, if let's say this is a quarter circle, then it will be 1/4 times pi r squared. This is if it's in degree, and currently we should be using the formulas at the top because we are doing it in radians, right? All right, so first thing we want to do is to find the arc, minor arc XPY. So minor means it's the smaller part. Major one would be the XAY, right, on the outside. So arc length will just be r theta, which means we use the radius of 14 times 0.8, and that will be your answer, which will amount to 11.2, right? All right, question B. Find the length of the chord XY. So chord is talking about one straight line that basically cuts through 2 points on the circumference of the circle. 2 points, one straight line that joins 2 points of the circle, that is your chord, all right? All right, to find this one, you have to look at the triangle XPY. Now this triangle currently, right, what we have is 2 sides and also the angle in between. Right? So when you have something like that, 2 sides enclosing 1 angle, you will basically use the cosine rule to solve for xy. Which means the subject, xy squared, equals to b squared and c squared will basically be the 2 sides that enclose the angle, which are both 14, minus 2 times of, again, the 2 enclosed sides. Cosine will be the angle opposite of the side you want to find, right? Which is here. So the side opposite, the angle opposite of side xy is basically the 0.8. Now take note that when you do this, right, your calculator mode should be in radian, right? Make sure you see your r at the top. So change the mode to radian, you see your r, should be seeing your r at the top, right? Or RAD at the top. Then you type in the solutions to find the answer. Which is always a good habit to write the more accurate answer first. So you can put them in the square root form. Maybe until 4 decimal place, and then get the 3SF answer. Remember, the final answer is always rounded off to 3SF unless you're talking about degrees. Angles in degrees is 1 dp. What else? There's also money is 2 dp, right? All right, next one, I'm going to find angle XQY. So to get to the angle on the right side, currently what we have are 3 sides of the triangle on the right. If you look at triangle XQY, we know that the radius are both 8, so these are the 2 sides on the right side. And then we just found in XY that is square root of 108.9763. Now with this, with 3 sides given, if you want to find an unknown angle here, you can also use cosine rule. That's one way, okay? So however, personally, as much as possible, if I can find an easier way, I will do that. Now this triangle here is an isosceles triangle, right? Due to the fact that it has 2 sides that is formed by the radius. So which means that if I can have introduced x to represent this angle at the top, I'm going to have angle here as x as well, right? To have angle at the bottom. So I can also use the sine rule, right? To get my answer out. And if I use sine rule, this is going to represent 180 minus 2x, agree? Okay, so that's another way, which means that you put it as sine of 180 minus 2x. The corresponding side to this angle is opposite of that, and that is your xy. Is equals to another pair, so you can, doesn't matter which pair you choose, they are the same. Why did I choose to put angle at the top? Because that's the one I want to find. Typically, if I want to find an unknown, I like it in the numerator rather than denominator. Yeah. Okay, so that's why you will do cross multiply and so on and so forth, and you do it. Okay, so that's one way you can do. The second way to do is to use, like I said just now, to use cosine rule, right? Which means that I'm not going to write any more. Actually, the sine rule also doesn't seem to be quite easy because there is still quite a lot of manipulation in algebra to be done, including the fact that you just created unknown sign, right? Which is actually a bit hard to do unless you have enough knowledge. So I'm so sorry I suggest this idea, but we will always have better. We will always be able to do things better if we have if we know some alternatives, right? So we're gonna do it cosine rule again with once again our xy square being the same. Why do I start with the subject? It's because the opposite of this side is the angle we want to find, right? That is basically your a square. So on the right side of b square and c square are both 8. Now at this point, there are some students who are not very good when it comes to manipulation of the cosine rule. Somehow they will try and probably join this whole thing together. No, you can't do that. It's because remember the order of operations state that you have to do first is the bracket, right? To do all brackets first, and then followed by powers and roots, which means that all the 8 square must be done first. So 8 square plus 8 square, that one you can join it up. I mean like 64 plus 64, 128. But before you actually do the subtraction here, the multiplication behind here has to be done first, right? Remember, in order of operations, times and divide got to be settled first before you can do plus and minus. All right, then on the left side here, basically I will do remove the square root. The square root and the square will cancel each other out. And then you can't just join the 128 minus 128 because this is another thing you have to multiply here before the 128 can minus that. So right now, how do you manipulate this is basically to make this part the subject. So I'm going to switch place. I'm going to make this whole chunk of stuff. I will move it to the left hand side. And currently is a negative coefficient attached to it, which means a minus, right? A minus subtraction will go to the left to become a addition. On the right side, basically, I'm just switch place so that the numbers can be together. Positive 108 will becomes negative. And then I can remove the coefficient of 128 by dividing by 128. Then finally, I can get to angle XQY by doing an inverse cosine. Again, take note that your mode should be in radians, and for radians, we will round off to 3SF in the final answer. All right, last part is to find the area of the shaded region. Now, the shaded region is a composite figure. So to get there, we have to find some basic shapes and add and subtract to get there, right? You have any idea to get to the answer? All right, so I hope that you did notice that you need to basically find this part here. This is known as a segment. All right, the difference between a sector and a triangle, if you remove the triangle from a complete sector, right, it's going to be called a segment. So the segment is usually the moon-shaped thing. And then also we need the area of the triangle on the right side here, XQY. If you can use the area of triangle to subtract this segment, that would be our answer, isn't it? Okay, let's start it off. So in order to find a segment, I must find area of the sector. Currently, again, it's in radians. So if you are in radians mode, the formula for area of the sector is half. Wait, before I write the formula, I should be labeling. Okay, area of segment XBY is equals to, again, the area of sector, which is half R squared theta minus the area of a triangle, which is half AB sine C. So it's the A and B are basically the two sides that enclose the angle in the middle. So sine C must be the one we did, right? In radians mode. This is not the final answer, so do not round off to 3SF. Write a more accurate answer. Perhaps until 4 or 5 decimal place is good, right? All right, and once you get that, then you would have to use the area of the triangle on the right. That's the next thing we want to find to subtract this segment away. So let's write that area of triangle XQY. It's another half AB sine C. This time around, the A and B are 8. And the angle in the middle here is your answer in C just now. But again, use the more accurate answer for that, which is the 1.42162, right? All right, so it will give you 31 point something, and then you will use this number to minus away the segment that will give you the shaded. All right, I hope you benefit from the lesson today. I will see you on the next one.